Okay, hello students. So today we are going to start with remaining topics, basic maths. Last class we have covered coordinate geometry, almost everything. We left the section formulas. So today we'll discuss section formulas and then we'll continue further. Maybe it will be better to see some applications of coordinate geometry, and then we will go into binomial expansions, right? So it will be quite interesting to go into that, and we will try to cover up that, and then small applications of algebra we will see, and then with this I think we will be winding up this uh, whole unit, uh, basic math. Of course vectors are also there, vectors also we can cover as a part of it. Of course, vector is a part. Otherwise, vectors can also be taken up later when we are completing the motion in two dimensions. We will see accordingly how can we finish it. Okay, so let us start this topic. First, section formula. Let us understand section formula. Section formula. So, suppose that there is 2 points A and B. Its coordinate is given x1 comma y1 x2 comma y2. 2 points, its coordinate is given. Now I want to find a point inside this line. This is a straight line AB, right? And I want to find a point somewhere here, anywhere this point can be. And I want to find its coordinate x comma y, so that this point is dividing this line in ratio m is to n. M is to n is the ratio in which this point P is dividing. So this point P is dividing internally. Okay. So this section formula first we will see for internal division. Internal division. So the x coordinate will be given as mx2 plus nx1 by m plus n. Okay. And y can be similarly written as my2 plus ny1 by m plus n. Okay. Now in this same formula we can do a modification. Suppose if I consider this ratio m by n as k is to 1, because the whole m by n can be taken as k, then k is to 1 we can take this ratio. If I do that, then I have to divide by n. So if you divide this ratio by n, you can definitely write it like this way. You can write this as kx2 plus x1 by k plus 1. Similarly, this can be written as k y2 plus y1 by k plus 1. This simple idea can make things easy. Okay. So, like this, we can apply the formula for internal division. This point P will be inside this line AB and it will divide this line AB in this ratio. Right. Similarly, we can find a point outside this line AB which will divide this line AB in the similar way, right? So let us take for external division. Suppose we have the line AB, this is x1 comma y1, this is x2 comma y2, and this line you can extend outside. Okay, so the point P will be lying outside this line and its coordinate x comma y we need to calculate. Now here this by this ratio is m is to n. Okay, the point P is definitely outside. So in this case for external division, external division, x can be written as m x2 minus n x1 by m minus n, and y can be similarly written as my2 minus ny1 by m minus n, and the same way We can write this in terms of k is to 1, kx2 minus x1 by k minus 1, and this is ky2 minus y1 by k minus 1. Okay, so what is k? This ratio m by n is called k, k is to 1. So that way also we can write the external division. So this is a way for dividing this line AB internally and externally. That's a very simple formula. It can be proved. If you go into the details, we can definitely prove it by maths, coordinate geometry, but let us not go into more detail of that. That we can leave it. Okay. Now, what is the applications of this? An application, one important applications is there. Okay. What is that applications? So, suppose, for example, not exact applications, but a similar applications of this I can give. Suppose that there is a line. Okay, there is a line, and there is a point. Let us say this is point x1 comma y1. This is a line. This point is a. I want to write the coordinates of point B, which is at a distance of, let us say, some distance L in this direction. Okay. I want to write the coordinates of point B, which is L distance in this side. It can be back side also. Then I can write that coordinate. But I want to write the coordinate of a point which is on the same line, and it is L distance away from this given point. So, of course, this is the idea of slope. I think slope idea will help us to write, because we should know the slope of this line. Slope of this line is, let us say, m. M is nothing but tan theta. What is tan theta? Tan theta means this triangle if you make. So this, if you write L, so this distance will become L cos theta, L cos theta, and this distance will become L sin theta, right? So if I apply this idea, then I can write this point as, because x is increasing, so I can write as x1 plus L cos theta and y1 plus L sin theta. If I write minus, then it will come this side, other point it will come, but back side it will come. Minus also can be written. But what is L cos theta? So tan theta, if I know, cos theta I can write, because in a triangle, if you know tan theta ratio is m by 1, then this becomes root under 1 plus m square. Right, so this point I can write this as x1 plus L cos theta. Cos theta is from 1 by this, so L by root under 1 plus m square, right? Cos theta base by hypotenuse. And similarly, y1 plus L sin theta. Sin theta is m divided by root under 1 plus m square. Okay. So that's the idea. We will be able to calculate a point. If I write minus, I will get a point on the same line, but this side I will get, because x coordinate and y coordinate will decrease. Here x coordinate and y coordinate will increase, right? So that's the idea, right? What else? And section formula has also got applications, like we want to calculate the midpoint, right? So midpoint if I want, suppose 2 points are there, and this point is x1 comma y1, this point is b, x2 comma y2. I want midpoint, so this midpoint, this is the midpoint, so I can calculate this as x1 plus x2 by 2 and y1 plus y2 by 2, just the average of that. Similarly, centroid also can be calculated. Suppose if this is a triangle, this point A, B, C, the triangle x and y1. This point B is x2 comma y2, and this point C is x3 comma y3. I want to calculate this centroid. What is centroid? What is centroid? So centroid is a point which is what do you say? Which is like, suppose if you draw the median. Median means a line which bisects the opposite sides. Okay, this is the midpoint. Let us say this is P. P is the midpoint of BC. Similarly, if I draw a line here, this, let us say Q. Q is the midpoint of this AB. Similarly, if I draw a line which is the midpoint of this, R is the midpoint of this. Right. So in that case, these are called medians, right? These are called median. Median is a line which bisects the opposite side. Bisects the opposite side. So wherever the medians are intersecting, that is called centroid. So this point is called centroid, and the coordinate of the centroid can be calculated as x1 plus x2 plus x3 by 3. Y coordinate is y1 plus y2 plus y3 by 3. So simple. Just take the average and you can calculate the coordinates of the centroid, right? Also, one important idea to note that the centroid divides this median in the ratio, what ratio? In the ratio 2 is to 1. Very important idea. So this, by this ratio, is 2 is to 1. Okay. AG by GP, this ratio is 2 is to 1, that we should know. So centroid divides the uh, median in the ratio 2 is to 1. Okay. Right. So these ideas are there. Then we can work out many questions on this. Definitely. So that's coordinate geometry. And then a lot of questions in coordinate geometry. One good book on coordinate geometry recently I was going through is Balaji Publications Advanced Problems on this. Okay, very good book. Very good book it is. I just give one question on this. Very good questions are there. Where is that? That book was there. I think Master sent me that book. Ah, yes, this is the book. Very good book, and I'll give a very nice problem on coordinate geometry in class. Also, I did it. It's a very interesting problem. The uh, rat no problem. Just leave that. Mm, algebra, calculus, coordinate geometry is 267. Okay, so this question I am giving questions on straight lines only. So straight line, there is a very good question, application oriented question. It is. Yes, this question. Let's try this, and I will explain the shortest way of solving this question. A piece of cheese is located at, so suppose you consider this as coordinate geometry x comma y. A piece of cheese is located at 12 comma 10. 12 comma 10 may be somewhere here, and there is a cheese here. Cheese, okay, located in a coordinate plane. A mouse is at 4 comma minus 2. 4 comma minus 2. 4 comma minus 2 may be mouse here. 4 comma minus 2. This is right now a mouse is position here. Okay, and is running up in a straight line. So mouse is going in a straight line, y equal to minus 5x plus 18. So what will be this y equal to, so I think the mouse is going in a straight line like this. This is a straight line like this. Okay, and this equation of this straight line they have given us y equal to minus 5x plus 18. That's the equation of this straight line. So that means mouse is going in this line. It may be going like this way. The question is, at the point A comma B, mouse starts getting farther from the cheese rather than close to it. So as it tries to go in this line, there is a point where he becomes closest. That is the idea. So we need to find the value of A plus B. So somewhere on this line, there is a point A comma B. Definitely at this point, this is like the perpendicular distance where as it is running, it is the closest to that point. So we need to find the value of A plus B. That is the question. Hmm? Let us try this interesting question. It is, try this, how to solve it. There are many ways of solving it. What is the best way to solve this problem? So first of all, let us take this perpendicular distances P, and P we can calculate. No, P we do not know. Sorry, we don't know P. Yeah, we can calculate because this is the line, right? The distance of a point from a line formula. Remember, suppose this is a point x1 comma y1, and this is a line ax plus by plus c equal to 0. Then this perpendicular distance P can be calculated as magnitude of ax1 plus by1 plus c divided by root under a square plus b square. We can get this idea to do this first. Let us calculate this point P, and equation of line you rearrange first. This line you bring it like 5x plus y minus 18 equal to 0. Write this equation like this and then try to put the value. So this perpendicular distance P can be calculated by substituting this. So 5 into 12 plus y is 10 minus 18 divided by root under 5 square plus 1 square. Calculate this perpendicular distance. So 5 into 12, 12 into 5, how much? 60. 60 plus 1, 70. 70 minus 18. So it is 52, right? So 52 by root under uh, 26. So that becomes root 26, right? Right. Hmm. That's the perpendicular distance. I think that's what it is, correct? Isn't it? Yes. So now we got this distance, perpendicular distance as root 26. But we want to find the coordinate of this point. Now one shortest way, just now we discussed, is shortest way is that if you can know the length slope of this line, we can calculate, and we know we have to go backward only. Backward we have to go, right? We don't have to go forward because this line is coming on this side. Definitely it is coming this side only. Right. So this point, what is the slope of this line? This line slope we know y equal to mx plus c. So if you compare the slope here, this slope of this line is minus 5. Okay. So this line, this green color line, let us say slope is m1. This m1 slope is minus 5. Let's say this has slope m2, and because these two lines are perpendicular, that slope m1 into m2 is minus 1. Minus 1. So m2 can be calculated. M1 is minus 5, right? So from here M2 becomes 1 by 5. Once you got M2, now you think of this line and writing this coordinate directly. Directly try to write this coordinate. How? because we know this line and this point we know 12 comma 10, and we know this length also root 26, and we want this point which is a comma b. The slope tan theta of this line we know, so this is tan theta, right? This tan theta slope we know, right? So this slope is 1 by 5, just now we have calculated, so tan theta is 1 by 5. So if tan theta is 1 by 5, that means this is 1 and this is 5, so this becomes root 26, right? So from here, what is sine theta? Sine theta is 1 by root 26. What is cos theta? Cos theta is 5 by root 26. But we have to come this side, means we need to subtract x and y. So this coordinate a can be written as, because this length will be p cos theta and this length will be p sine theta. So we need to subtract x from x coordinate this length and from y coordinate this length. Okay. So a will be equal to this 12 minus p cos theta, direct answer, and v is equal to 10 minus p sin. Direct answer will get in one step. So 12 minus p, p length we have already calculated root 26, and cos theta just now we have calculated 5 by root 26. So that means 12 minus 5, 12 minus 5, 7, and this is 10 minus, same way, root 26, and sine theta is 1 by root 26. So that means 10 minus 1, 9. So this is 7 and 9. We got this. This question has become so easy now. So a plus b is going to give us 7 plus 9, which is nothing but 16. That's the answer. Good application with the coordinate geometry. Like that, so many questions are there. Maybe one or two more questions we can try from this. Also, we see one more applications of area. Suppose if there is a triangle whose coordinates is x1 comma y1, b x2 comma y2, and c x3 comma y3. And if I want to calculate the area of this triangle, area of triangle ABC can be calculated as half magnitude of x1 y2 minus y3 plus x2 y3 minus y1 plus x3 uh, y1 minus y2. And I think this term can also be written in terms of determinant form as half um, how can we write as determinant form? I think x1 x2 1 y1 y2 1 1 1 1, isn't it? With a coordinate way we can write it. Exactly, I'm not sure. If I write it as 1 x1, no, might be we cannot write it. But for factors we write it. Leave it. Okay. So this we have to remember it. Magnitude it is. Magnitude means area cannot be negative. So we have to calculate in this way. Hmm. But there is a way of cross product calculation. Cross product calculation I will take in vectors. Using cross products we can calculate this. Okay. That will take off. So this is area application, area of a triangle. Let us take some. So note that if this area is 0, let us say if the area is 0, if this factor area is 0, if area is 0, the points A, B, C are collinear. A, B, C are collinear. Collinear means they are lying in the same straight line. If they lie in the same straight line, the area they will not form any area. They will not form any triangle. So sometimes this idea is used to check collinearity. If three lines are in the same straight line, then this term must be 0. So they are collinear. Okay, so this is used in some places. Then let us take up some question. Hmm. Let us try a question. Question is, there is a triangle whose coordinates are given as 2a comma a. This coordinate is given as a comma 2a, and this coordinate is given as a comma a. They are saying that enclose a triangle. The area of this triangle is given. Area is given as 72. Then what is the centroid? They are asking coordinate of centroid. Let us say centroid is x comma y. That means x will be sum of this means 2a plus a divided by 3. So 4 by 3a. Y coordinates will be a plus 2a plus a by 3. This is also 4 by 3. So that means a, if I calculate, I can calculate the centroid. How to calculate it? Because they have given this area, we can try this area formula. So area formula is half magnitude. Let's start with 2a. So 2a minus a plus a, a minus a plus a minus 2a. So from here, this I'll multiply cross, so this becomes 144, and this becomes magnitude, it is so 2a. 2a minus a become a, so 2a into a 2a square. This becomes 0, right? And this becomes a into minus a square it becomes. Okay, so that means it becomes a square is equal to 144. So a becomes equal to 12. A becomes equal to 12. Definitely a can be plus minus because we don't know a is positive or negative. So plus 12 or a can also be minus 12. Both possibilities are there. So if I take both possibilities, then the coordinates of x, y, x and y can be put the same coordinates. So 4 by 3 into 12. 12 if you multiply 4 by 3, so 4 16. So plus 16 or or x is equal to minus 16, y also equal to minus 16. So this is the possible answer. 16 16 or minus 16 minus 16. That's the coordinate. Hmm? So definitely we will be able to solve problems like this way. Isn't it? It's not difficult. We can solve this type of problems. Any other type of applications are there? Area of triangle form. Okay, I think more about detail in maths we can see more details about this, because then it will purely become maths otherwise. Purely maths. So let it be in okay, one application of physics look like one physics application is there. Let's take that. So a rod of AB of length 3 rests on a wall. Okay, maybe this looks like a good question. So this is ground and this is wall, and there is a rod which is lying like this. This is a rod, and they are saying that this point is origin 0 comma 0, this point is B, this point is A. Rod AB, length of the rod is given 3 meters. And point P is a point on AB. Somewhere point P is there. AP is to PB is 1 is to 2. So this point is P, and this ratio AP by PB is 1 by 2. Okay. If the rod slides along the wall, then the locus of P lies on. The question is, suppose this is sliding. This is sliding means this point B is going like this way, and this point is coming like this way. So how does this point move? That is the question. How does this point move? What is the equation of the path moved by the point P? It's a good question. Huh? This is good question. So this length AB, they have given us 3. I am writing here 3. This I will eliminate here. Okay, so how do we solve it? We don't know how it is moving. It may be moving in some path because rod may come down after some time. Suppose rod comes like this way. So this point P may go somewhere else. So it may form some path. What kind of path it is, that is what we have to figure out. Okay. So at an instant, let us say that at an instant it is making angle theta. So suppose this rod is at an instant making angle theta with x-axis. So this length of the rod L, let us take, this rod length is constant anyway, and this point P will have, let us say, x comma y. This point will have coordinate. So remember, total length is L, so this will be L cos theta and this will be L sin theta definitely. So this point coordinate will be L cos theta comma 0, and this point coordinate will be 0 comma L sin theta. L is the length of this rod. So now they have given that this point is dividing it in this ratio 1 is to 2. This ratio is 1 is to 2 internal division. So point P, now let us write x coordinate. X coordinate will be mx2, that means 1 into L cos theta, plus nx1, 2 into 0, divided by 1 plus 2. Right. So from here we can solve x as L I will substitute. L is equal to 3. So 3 cos theta by 3. So this becomes just cos theta. Similarly, y coordinate also I will calculate. Y is equal to m y2. So 1 into 0 plus 2 into L sin theta divided by 1 plus 2. So from here, what do we get as y? Y will get um, yes, 2 sin theta we get, right? Correct. So now x we have got cos theta and y we have got 2 sin theta. We want relation between x and y, means we try to eliminate theta, right? Theta is an unknown thing, we can eliminate. So from here sin theta we can get, from here we can get sin theta, which is y by 2, and from here cos theta is x, and we know sin square plus cos square is how much? Sin square plus cos square 1. Yes, we'll substitute that. So sin square means here y square by 4 plus x square is equal. This is what the equation is. Now, it is an interesting equation. Yes. So what equation does it represent? Can you now tell me what equation it is representing? X square plus y square by 4 is equal to 1. Is it a parabola? Is it a circle? Is it a ellipse? Is it a hyperbola? What it is? Parabola, what type of equations are there? Last class we have discussed that. Parabola standard form, you remember? One side is x square, another side is y, or one side is y square, another side is x. So that is quadratic. One is like quadratic in x, other is linear in y, or quadratic in y and linear in x. But here both are like quadratic power 2. So they cannot be parabola definitely. Think about other thing, ellipse. Think about ellipse equation. What was the standard form of ellipse? Ellipse equation. Hmm. Yes. Now it is ellipse now. A and B are different. Here 1 you can write 1 square. 4 is like 2 square. Right? So that's what is ellipse. So this equation is nothing but it's a ellipse. Oh, nice point. So that means this point P is moving in such a way that its path is a ellipse. Right? That's what it is. And I think here we should also note little bit about circle. Circle, I think we did not cover that. Let us cover circle also. So circle is what? Circle is a locus of the point which moves in such a manner that its distance from a particular point is always fixed, which is called radius. Radius. So this point is called center. This point is called center, and this point P can be anywhere on this, right? So P can be anywhere on this, but P is moving in such a manner that its distance from the center is radius, and this center will also be fixed point. Let us say center is x naught comma y naught. X naught comma y naught is the center, r is the radius. To draw a circle you need two things, center and radius. Center and radius, if you know, you can draw a circle. So I want to get the equation of this circle. Equation of this circle means we want relation between x and y, and radius is given and center is given. So very simple, definition we can apply here, that this distance formula we can use. This distance will always remain constant. So distance formula is root under x minus x naught whole square plus y minus y naught whole square. This is equal to r because this is going to be constant. So now let's square this. So x minus x naught whole square plus y minus y naught whole square is equal to r square. This is the equation of a circle with center x naught comma y naught and radius r. That's all. And if you want, you can open it also. It's not that we cannot open it. We can open this also. So a square a square plus b square, we can open this 2x naught x plus y square plus y naught square minus 2y naught y is equal to r square. So if I bring in terms of x square plus y square, so x square plus y square minus 2x naught x minus 2 y naught y. Other things I will take that side. Constant terms, let me take that side. So that becomes r square minus, or I may bring this side only, no problem. So I keep this plus x naught square plus y naught square minus r square is equal to 0. This type of equation is also, when you expand this, will become like this. So here, whenever such equations are given, we can try to figure out that this coefficient of x, which is minus 2x naught, this coefficient of x is minus 2x naught. So this x naught can be calculated as uh, coefficient 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 of x. You take coefficient of x is what? Minus 2x naught. So that you divide by, yes, you divide that with minus 2. If you divide minus 2x naught with minus 2, you will get x naught. Similarly, this y naught can also be calculated as coefficient 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 of y divided by minus 2. We can get like this. Now, how do we get radius from there? Radius we can calculate from this term. This term we can calculate this. I think if we can bring in this form, then we can do that. If we can, definitely, if we can bring in this term, then we can do it. Anyway, this is what is the idea behind it. We will be able to calculate this. Okay. So let's take any question on circles also. Any questions are there? We can take that. Okay, this looks a good question, application oriented question. So question is that uh, the length of chord of contact point 4 comma 4 with respect, there is a circle here. The equation of circle is given x square plus y square minus 2x minus 2y minus 7 is equal to 0. This is the equation of a circle. Chord of con length of chord of contact of point 4 comma 4 with respect to circle. What is meant by this? We can definitely draw this circle, and where will be the center of this circle? We can calculate the center, right? Just now we discussed. So I think center is 1 comma 1, correct? The coefficient minus 2 divided by minus 2, coefficient of 1. We can. What is the radius of that? I think you need to. No, no, that is not radius. You need to bring in the standard form. So see, x square minus 2x, we club together. Similarly, y square minus 2y, you club together. Okay, so plus 1 you do, plus 1 here also do. So minus 7 is there, and that will become minus 9, correct? Is equal to 0. So 9 you take that side. This become x minus 1 whole square plus y minus 1 whole square. Now you can see this is r square, so radius will be 3, right? Standard form always we can bring and we can do the comparison. Okay, so now the thing is that they are asking length of chord of contact of point 4 comma 4. Does 4 comma 4 lies on this 4 minus 1 3? No, 4 doesn't lie in that circle. So 4 comma 4 will be somewhere outside or inside, we do not know. Length of chord of contact of point. What does that mean? Length of chord. Length of chord of contact. Length of chord of contact of point 4 comma 4 with respect to this circle. With respect to this circle. They are asking this only. What is the meaning of this? Length of chord of contact. Length of chord of contact of point 4 comma 4 with respect to this circle. 4 comma 4 does not lie because here if I subtract 4 minus 1 3 square 9 9 plus 9 it is not lying here. 4 comma, where it is it inside or outside? It is definitely not lying on, because if it lies on circle it will satisfy the equation. It is not satisfying this equation. So is it lying inside or outside? We can draw this circle. It's not that it's a big thing to draw. We can draw the circle in coordinate geometry. Suppose rough diagram you draw. Suppose this is the coordinate y and x coordinate it is. This is 1 comma 1 means here it is 1 comma 1. And if I draw this circle of radius 3, so definitely this is 1 and this is 1. So that means radius is 3 means if I say this is 1 comma 1, radius is 3 means uh, this is of course 1, 2, 3. Like this circle will be there. Circle will be of course cutting the coordinates somewhere. Okay, it will be cutting the coordinates. So it will be cutting wherever it has to cut. But the point 4 comma 4, because if you see here radius, it may go, it may lie outside somewhere. 4 comma 4, right? 4 comma 4 can lie outside. What it means that length of chord of contact of point 4 comma 4. 4 comma 4, how it is chord you will make. The question is not coming clear. Length of chord of contact of point 4 comma contact upon with respect to the circle is. How also do we know that point lies inside and outside? Suppose if you write this equation of x minus 1 whole square plus y minus 1 whole square minus 9 is equal to 0. If you try to satisfy origin, let us say origin. Origin means 1 square plus 1 square will come negative, or even this point 1 1 you satisfy, this is coming negative. So any points lying within inside that this will give negative. Points outside lying must give positive. So if you substitute 4 4, it will come positive. So 0.44 is outside only. But I think this concept of length of chord of contact of point 4 comma 4, that is not getting clear with respect to. So are they asking that we have to make tangent? No, tangent is different thing. No, tangent will be different thing. Chord they are asking means it has to cut the circle. So how do we cut this circle? They have to clearly explain. They have not explained clearly. I think. Length of chord of point 4 comma 4 with respect to this circle. Chord means what? Chord means it will cutting somewhere. I think question is not clear because we can join this line. Huh? What do you think? Okay, might be. You're correct. I don't know, but let us check that. So if we make tangent like this way, huh? Right? Tangent like this way, it may be touching here and here, and then the length of this, right? Hmm, might be, yes. Then how to solve it? Hmm, length of, hmm, how do we solve it? If we get any point here, these points coordinate, if we can get, then we can solve this. But how do we get that coordinate? Hmm, we can try to join these two points. That one will be cutting it normally. Definitely it will cut normally. So these distances will be equal. Hmm. And if I make also like this, so this will be 90 degrees, right? So this is tangent and this is 90 degrees. After that, what can we do? 90 degrees. This how do we get it? How to find the length of tangent? Is there any formula for that? Length of tangent. This length, how do we calculate? Definitely, there will be a formula to calculate the length of tangent in a circle. If you go into detail in maths, there will be some formula to calculate length of tangent. And if we calculate length of tangent, hmm, yes, then we know radius is 3, so this distance will be 3. This distance will be 3, right? And we know this. We can find this. Then after that, if we can calculate this point we can calculate. Yes, I think that will work. Okay, let's try this. So this uh, this length between 1 and 3 3 is how much? This length 1 comma 1 and 4 comma 4. 4 comma 4. So this distance, let us calculate distance point formula. Let us call this distance d. So root under 4 minus 1 3 square plus 4 minus 1 3 square. So 3 root 2. 3 root 2. Okay, so this distance is 3 root 2. And this is 90 degree. So this will be 3 only because it is hypotenuse. Okay, right. So that's 3 3. Is it a square or what? Looks like right. It's looking like a square only, no? Because this is 3 3 and this is 3 3. So that is like a square. That is only possibility. Square, that means this is the diagonal of the square. Diagonal of square means this only 3 root 2. So the answer should be 3 root 2. Right. Correct. Sometime it may not be square. That time it may be little complex. Okay. Fine. So I think we can do with this. That's all. Coordinate geometry is over. Done. So what else? Then we can go next. I think other students have not joined till now. So let's continue this topic. We can try to complete the binomial. Now let us understand binomial expansion. Binomial expansion. So binomial expansion means a plus b power n. Expansion if we want to do. So what we can do is a power n we can say, b power 0 we can say, like that, and powers of n we can keep on decreasing, then power of b we can keep on increasing, n minus 2 b power 2, like that we can continue, and the last term will have a power 0 and b power 2. And here the coefficients of this expression is nc0, nc1, nc2, like that it will go, and last term coefficient is ncn, right? That's how it is explained. But what is ncr? That also I will explain what is ncr. Yes, Sam. So I'm just continuing little bit of grade 11 topics to cover up this. Okay. Then we will start. Okay. So NC0, NC1, NC2, like that it continues. So this is what is NCR explanation. I will give NCR. It is factorial of n by factorial of r by factorial of n minus r. And what is factorial means? Factorial of 1 means 1. Factorial of 0 also means 1. Factorial of 2 means 2 into 1. Factorial of 3 means 3 into 2 into 1. Factorial of 4 means 4 into 3 into 2 into 1. Like that, factorials are defined except 0 and 1. All others are defined like this way. Right. So that is what is binomial expansion. We can we can expand it like this. Now we can do some approximation, like suppose one of the term I can take as x, another term I can take as 1, to get a small idea about that. So let us take a as 1 and b as x. Substitute in this expression a as 1 and b as x. So we will get 1 plus x power n, nc0. A is 1, so a term will become vanish. B term is first 0 only. Next nc1, b means x plus nc2 x square. Like that it will continue up to last term ncn x power n, like this. Okay, now let us try to put the values of nc0 nc1 here. So what is nc0 means? Factorial of n by factorial of 0 by factorial of n minus 0. So this is factorial n, this is factorial 0, this is factorial n. So definitely this get cancelled and factorial 0 is 1. So similarly, what is nc1? Factorial of n factorial of 1 factorial of n minus 1. So n factorial means n into n minus 1 into n minus 2. Like that, we'll keep on writing it up to 1. Similarly, here this is 1 factorial means 1. N minus 1 factorial means starting with n minus 1 with then n minus 2. Like that, we'll keep on writing up to 1. So everything else will get cancelled here. So you will be left with only n. Will be left with n. Similarly, what is nc2? nc2 also try to expand. nc2 factorial of n factorial of 2 factorial n minus 2. This can be written as n minus 1, and we can also write this as n minus 2 factorial. This factorial 2 means 2 only will come, and this is n minus 2 factorial. This will get cancelled. You will get this as n minus 1 by 2. Okay. So similarly, nc3 factorial also now we can write nc3 factorial is factorial n factorial 3 factorial n minus 3. This can be written as n minus 1 n minus 2, and then we can write it as n minus 3 factorial, and then this is 3 into 2 into 1, and this is n minus 3 factorial. So this n minus 3 factorial will get cancelled. It will be n minus 1 n minus 2 divided by 6. Like that continues to last one. So last one it will go ncn. ncn is factorial n by factorial n by factorial n minus 1. So this will be n factorial, and this is 0 factorial. So this will become 1. So now let us write that expansion in terms of this. So 1 plus x power n can be now written as um, what? Start with this first factorial. The first term. First term is nc0. nc0 is 1. Then nx, like that. Let us write that. So first term is 1 plus nx plus n minus 1 by 2 times x square plus n minus 1 n minus 2 by 6x cube. Like that it will continue. Last is plus x power n. Right? Like this. This is the actual expansion using binomial. using binomial, it is the expansion of this. Now, in this expansion, we make approximation. In physics, what is useful approximation, that we should know. So, we have to put x, suppose x is very small as compared to 1. Suppose x is very small as compared to 1. Then what? Then what? Then we will put x is very small means fraction like 0.001. So the square cube terms can be neglected. Can be neglected means we can ignore that. So 1 plus x power n can be taken approximately as 1 plus n. Note that this is the approximation. This is not a exact method. We are just doing approximation, and now this is generalized. Now generalized means it may be power can be anything, so I'm not going to do that further, because any power can be there, maybe positive power, negative power, whatever it is. Here also it can be plus x, minus x, doesn't matter. You have to apply the same approach, right? But what about the negative number factorials? Does it exist or not? I think may not be. Maths, you have to check with a maths expert whether negative factorial exists or not. What do you think? Negative number factorial exists or not? So then how do you do approximation for that? But we are using the same formula. Let's not go into maths, because my maths is not that much. Okay, so let it be. If I go into maths, then I have to read some books more. I have purchased it to read it, but I am not getting time to read that. One books I have got, two set of books I have got from this Sivalma, that is physics related only. Um, that's a good book. He has written a lot of maths in that. Sometimes I read, but time is not there now. But I'll read. Okay, but let's not go into more detail of that. But there are some series which are very interesting. That is Maclaurin series and other thing. Maybe that I will tell you. It's a very good means idea behind it. Maclaurin series and Taylor series. Those Maclaurin series and Taylor series are very good actually, because based on this, lot of expansions formulas are based. So maybe I'll give you that. Let me see that formula for that. Do you have idea about that? Maclaurin series. Huh? Have you studied about Maclaurin series? No? I will give that. It has got applications. Hmm. Maclaurin series comes from Taylor series. Taylor series I will give, then you will understand. But once I tried to get the meaning of Taylor series, I could not got more detail about that. But let's understand Taylor series. Okay, Taylor's Taylor series. Taylor series about x equal to a. What is Taylor series means? The function f of x can be written as f of a plus x minus a f dash a plus x minus a whole square by factorial 2 f double dash a plus x minus a whole cube by factorial 3 f triple dash a, and this continues. Okay, okay, so now let me explain what this idea is. It's a very nice, beautiful idea of maths it is, and This single f dash means single differentiation, f double dash means double differentiation, triple dash means triple differentiation. Okay, I'll explain what is the meaning of this. Very, very beautiful meaning it has. Suppose, for example, there is a function. There is a function, and let us say that you know this particular point. Okay, this point is this point, you know, that means its value is a, and this is f. F of a means y. Okay, f of a means y, because it is y equal to f of x. Y equal to f of x means if you substitute x as a, y will get f of a. Okay, so that means there is some x here, x is a here, and y is f of a. This is y. Okay, now I want to find out the value of, you know, I want to find out the values of this function. So how do I calculate that? So if I take any point here nearby I take, nearby if I take, not very very far away, nearby if I take, then this point will become x, right? This point will become x and this point will become y. So this distance will become what? This distance will become x minus a, because that is delta x, and this become y minus a delta y minus f of a it will become, correct, no? Because y minus y2 minus y1, and it is x2 minus x1, delta y by delta x. That is what is theta here, correct, na? Are you getting this? Because there is a small triangle, can you see here? This is a small triangle formed. In this small triangle, this is like delta x delta y. If I assume that this point which I am taking as x comma y is very very close to this point, then in that case we can make an approximation. Suppose this point x is very very close to this, then this is almost like a straight line, right? X minus a like delta x and y minus f of a, and this is tan theta. So tan theta is what? Tan theta is like dy by dx. Although it's I'm taking this x very very close, so this is dy by dx only, which I am calling at which I am calling as f dash a. Why f dash a? Because this dy by dx is at this point. Okay, dy by dx is there, but which point? Because at different point dy by dx is different, slope is different. So this dy by dx is at this particular point where the coordinates, where the value of x is a, right? That's what it is called. Now can you tell tan theta in this triangle? Tan theta is y minus f of a by x minus a. What did you get now? Just cross multiply. F dash a into x minus a is equal to y minus f of a. So from here we got y. Y we got as f of a plus x minus a into f dash a. Did we get this same series? But up to two terms, I think we are getting, check that. We have got the same thing up to two terms. F of a plus x minus a, right? Can you see that? Up to two terms we got it. So the same idea is that which you can expand it up to no n number of terms, and we are going to get more terms, and that gives a very good definition of this, right? So those who are maths expert, they will appreciate it more, because this is a very very fundamental, you know, idea, and using these Taylor ideas we make what we make this Maclaurin series. Maclaurin series means a you put as 0. So what is Maclaurin series? That also I will explain. Maclaurin series. So Maclaurin series is nothing but it is Taylor series only. It is Taylor series about x is equal to 0. That a has become 0 here. Okay, note that. So if I put a 0, then fx becomes f of 0 plus x f dash f dash 0 into x, or x into f dash 0, x into f dash 0 plus x square by factorial 2 into f double dash 0 plus x cube by factorial 3 into f triple dash 0. Like this you can continue whatever you can do. Okay. Now I will explain some of the series for this. You can note the sin x expansion cos x. If you remember this formula, you can write anything. See, there are there are sometimes struggle happens that what is expansion of e power x, what is expansion of sin x, what is expansion of cos x. I just give you this idea that you, if you know this formula, you can write the expansions of many other things. I will write the expansion of sin x here. Okay, let me write the expansion of sin x using Maclaurin's series. So suppose if I say sin x, f of x is sin x. So this is sin x. Sin x can be written as f of 0 means substitute 0. Sin 0 is what? Sin 0 is 0 plus x into uh, f dash x means what? F dash x, first you do sin x differentiation is cos x. Cos x you got and put 0 there. That means it will become 1. Correct? Plus x square by factorial 2 double dash. So sin differentiation become cos, cos differentiation become minus sin. Cos differentiation become minus sign, but again you put 0, so it will become 0 only. Then x cube by factorial 3. Then triple differentiation means you got minus cos, right? Minus cos again you differentiate. So first you differentiate sine, it become cos. Cos you differentiate become minus sine. Minus sine again you differentiate, it become minus cos. And you put that value, so it will become minus 1. So like that you will be getting some series. Okay, like that. So this expansion of sine comes as x minus x cube by factorial 3 plus x5 by factorial 5 minus x7 by factorial 7 and so on. This is what is the expansion of sin x, which you have to mug up. Okay, if you want, you mug up this. That's what it is, the expansion. Okay. So now the thing is that here why, now you will understand why do we take sin x x. Generally, no, people ask question, we take sin x x when x is very small, but how much is small? How much small we do approximation? So here you need to note that x has to be very small as compared to 1. So if x is very small, and remember x is the angle in radian, definitely you have to remember x here represent angle in radian, not in degree. It is representing angle in radian. So if that angle in radian is very small as compared to 1, then sin x can be just approximated it as x. Okay, that's what we do. So this I have just written expansion of sin x, but you can now use that idea to write expansion of cos x, tan x, whatever function you have, you expand it. E power x ln 1 plus x, all these things can be expanded using Maclaurin's expansion, right? Because there are expansion formulas are there, log and all that expansion formulas are there. So we can do that, but let it be. Okay, that's all. I think today we have completed this binomial approximation also. Applications and other things we can see in the next class, right? So today we are winding up this, then we are going forward in the next. Okay, right? So so let me just